Alright then, today I'll be experimenting these two things. So yeah, let's start with the first keyword. So why are carbohydrates important? And I actually can just look at my notes instead of ChatGPT, but and so without writing it down, it's sort of an energy source or a storage of energy that is used later on for like respiration stuff. So So, okay, it's not really a chunk, but this is how it goes. So it says monomers, condensation, you get polymers. And I do know the reverse, which is hydrolysis. And it's like a formation of the covalent bond in general. For carbohydrates, it will be glycosylated bond. But yeah. Okay, let's move on. Does make sense. The hydroxyl is for interaction with water. Makes it polar, I guess. That's the ideal aldehyde ketone is the involved in reactions of oxidation and reduction. Okay, so I did learn about, was it photosynthesis or respiration where the glucose is it reduced? Wait. Yeah. It's the carbon fixation Kelvin cycle, where you have like the PGA to PGAL, which is this one's aldehyde. This is not too sure. I think it's related to that. So when they change functional group, then what's the point? I'm just interested. Allowing for reduction and oxidation. Okay. Glycosylated bond is just to form together. Yep, that's about it. So I'm just curious about this. Why is the functional from keto to aldehyde? PG Kelvin cycle PGA to PGAL. Okay. Energy storage. So, is it more? Interesting. It's very interesting. So, okay, these I think it's just processing nodes now, not really any chunks. So it's like storage of energy. Okay. Next word, condensation hydrolysis. Why is condensation important? Actually, hydrolysis and too. They are antagonistic terms. Oh my god, it's a shame. Interesting. So, for some reason, both these processes are also for storage and release of energy, which is, I think it's a coincidence, not gonna lie. Okay, so for right now, this is a chunk, I suppose, which is lucky. Do not bank on that, but apparently that's the same function. Let's go. That's good. That's really lovely. And we've covered these two already. Hydroxyl group. Why is hydroxyl group important? Because it wants to form interactions with water or make it polar. But I don't see how it fits in here. That's the thing. Okay, how about like interact with water? So it's like okay. Monosaccharide, disaccharide is how monosaccharides and disaccharides related. Okay, I'm not too sure if this is related to what I know, but I've heard that you should eat more like polymer. What is it called? Like, is it starch? No. The polymer type of carbohydrates complex carbs. Ah, yes, complex carbs, because they are less, not less reactive. They break down slower, which I think means less reactive anyways. And so they don't break down and release the energy so fast, rather than like sugars, which are simple carbohydrates or something like that. So okay, I think this is the same as the polymers and polysaccharides and monosaccharides and disaccharides, where the more bonds you have to break, the better it can store energy, because you have to break the bonds before you can release the energy. But once again, do I really see that here? How do I fit this in? I guess I can just write breaking of bonds. Sure, I guess. Next up. Jesus Christ. What the hell is this? Interesting. So smaller ring is more reactive. Okay. Okay, I think this is off track, and yeah, let's move on to the next one. Linear. Oh, okay, I'm curious about this. Interesting. Just now the aldehyde and ketone group. Okay. Less stable. Okay. Ring form less stable. And usually for biology, I think reasons of importance is actually just the function. So there's sort of a comparison between, okay, it's off track, but the 5-sided and 6-sided ring in terms of stability, but for, and then there's another comparison between linear and ring. I think this one will be more distinct, I suppose, in the stability. So they're both NGs for NG. Okay. Oh, never mind. I was gonna ask about precursor, but I just saw this. Okay, okay. So there's a distinction between, I would say this is ring glucose and for struct. For scaffold, you have the linear glucose. Might be the same thing, but I'm just gonna put cellulose here. Okay. Hmm? Jesus Christ, this is like the double bond and single bond shit. Whatever. Oh yeah, we don't have the enzymes. As humans, we only have enzymes to break down the alpha glucose, the alpha glycosidic bond, rather than animals who eat plants that can digest, that has enzymes to digest the, what is it called, beta glycosidic linkages. So interesting. Fructose, galactose. Okay, we are getting somewhere. So, my hypothesis is change in function group leads to change, it leads to the function. And the functions include being a structural scaffold. I'm gonna dump it here. I'm too lazy to turn it around. Why is this like this? Holy shit. Here, this should be here too. Okay, we're getting somewhere. Acidic bond, reducing sugars. Why are reducing sugars important? And seriously though, why do I even watch lectures at this point? I might as well just do this. So good. But the keywords though, that's the problem. Keywords still need the notes and practice papers or lectures, I'm not too sure. Hypothesis number 3. Installed stability is determined by whether you have a reducing end, have reducing end. I'll draw it out later using abstract visual. Okay, so Oh yeah, then the 5 was the 6 carbon ring, or 6-sided ring. What else? Stability. Yep, okay. Nope, it's just... ignoring the fact that the arrows are all messed up. Holy shit. Interaction with water. Okay. Okay, we got to the part where last year when I made this map, it's all just about the like starch and cellulose, which is basically the one where I like have to memorize all its functions and shit. But this time, with this structure, I want to see whether these two things can fit in, which intuitively they can, because cellulose is the storage one, structural scaffold, while the starch and glycogen is the release and storage of energy. So what I actually want to do now is to see how these things are impacting or related to glycogen and starch. And so I'll look at my notes, because those are the things I'm supposed to memorize, but I'm not going to do that because I'm gonna forget. And if you actually need to memorize these things, just do it 2 weeks before using your flashcards, all the shit. But it's better to be able to conceptualize it. Okay, that's not the right word. More of to find relation through these things and link it to your map or knowledge schema. But knowledge schema already looks like this, like it's all like the different stuff related to each other. So yeah. For the psychopaths that watch until here, just ignore that and we will continue on. I'm too lazy to crop it out. Please don't backstab me, thank you. Okay, So I'm actually gonna just read it out. If it, I don't think it's allowed, but screw it. Anyway, you can find this anywhere else. So for starch, right, we're gonna touch here. It's like SPF, so it's structure, property, function. But here it's just structure and function. And so the structure is large molecules with several hundreds of glucose residues, and it links to being insoluble in water, which here, and of course that leads to the storage. So my idea being it's released, storage and release here anyway, so interaction in water. And we already have one more thing here. So if I'm gonna rechunk it or like just rewrite it, it's one part of it is interaction with water, and the detail is I'm just gonna draw like, okay, behold my art skills, holy shit. Okay. So the next point is glucose residues bonded by the alpha ones for glycosidic bond that which function is to dehydrolyze and release the energy. Oh, also helical coil. So release. Okay, so storage would be. Am I gonna draw DNA? Maybe. I don't know. Helical coil. What's a helical coil? I have no idea. Helical coil. It's still compact. Okay. Can. Next point is anomeric carbon of each glucose monomer is inverted, which leads to stability. So I want to say okay, next point, last point. Amylopectin is highly branched, therefore many sites of hydrolysis for rapid release. So I'm just gonna draw a tree branch. Shit, I don't know, my art sucks. But keyword anchoring with amylopectin, because I don't think anyone with the same mind will look at this and be like, yep, this is amylopectin. So you write the keyword down right beside it or some shit to forgot about this guy here. Okay. I'm just curious where on earth is amylose here. I couldn't be bothered. Anyways. you know what, I'm actually gonna leave this as an empty chunk, because I'm just gonna ask what, like, is this okay? Or should I just actually just remove the box? Honestly, I'm not too sure. So the next one is cellulose, which is the structural skeleton. And once again, I'm gonna read out the structure and function. So once again, it's similar to, okay, I see a similarity, which is this thing. Okay. Okay, this seems good. Yep, that's about it. Adios.